we are continuing the inelastic collisions, right? So inelastic collision, as I told you, for example, if this is the wall or this is the ground, right? If the ball is, if it is hit with the speed v and the coefficient of restitution is e, what is the rebound velocity? Can you tell? If it hits with the speed v, the coefficient of restitution is e, so therefore the rebound velocity will be ev. You understand this thing or not? You tell. Right. For example, now if we drop the ball from its initial speed 0 from height h, right? So what will happen? It will hit the ground with some velocity v, and then it will rebound with the velocity ev. It will move up to a small distance, less distance as compared to this, and it will come back. When it will hit again the e square. It will hit again with the same velocity, and it will rebound with the speed e square v. Then it will hit again with the e square v, and then it rebounds e cube v, right? So in this way it will continue to move, right? So this is the way. If it is drop, it will move, bounce, rebounds, and finally it come to the rest. So in this case, what you have to find? You have to find, in this case, find first total time, total distance covered, total distance covered by ball. Also you have to find total time taken by ball to come to rest. This is the question, right? The total time you have to tell, and then the total distance covered by the ball before come to rest you have to find. This is the question. Copy this. So what you have to remember, for the motion under gravity, if the speed is u, right, can you find what is the total time of flight for this motion? What is the total time? Say 2u upon g. Did you remember or not? Right. And if it is released from rest, listen one thing. If it is released from rest and this is the total height, so what is the time taken by the ball? Yes, the time taken ball to hit the ground is what? Say h is equal to half gt square, if you remember. S is equal to ut plus half at square. The acceleration is, initial velocity 0, acceleration is g. Time is root 2h upon g. Right, this is the thing. Okay, in this case, first we will find the total time taken before come to rest. How to find? Listen one thing. From here to here, what is the total time? Suppose this is the time t. The h, right, for the before first collision, what is the time? You tell. Root 2h upon g, right? Root 2h upon g. So from here to here, the total time I'm writing, right, and this is equal to root 2h upon g. Is it clear? Very good. If it hits with the speed v, so what is the speed v? You tell. V square is equal to u square plus 2gh. The initial velocity is 0, right? So, and this is the root 2gh. So this is the speed v. You have to understand. And the rebound speed is ev. So from here to here, the total time I am assuming it is t1, right? So what is the t1 you will write? The t1 you will write 2u upon g, if you remember. But instead of u, you have to take 2 ev by g. Is it clear? For this section. For this part, the speed is u square v. Did you remember t is equal to 2u upon g? Should I explain how does it come? Yeah, yes. If this is the speed u, the final speed is v. So v is equal to u minus gt, or right, final speed is v, u minus gt, so time is equal to u by g. So the same time it comes to in descent. This is the ascend motion, time is same, u by g, and descent motion, the time is same, u by g. So total time is what? Say 2u by g. Yes, you can copy this first. So for this section, after first rebounds, right, what is the velocity, say ev? Also, when it will hit back, the velocity is ev. So what is the total time taken? Suppose the t1. So t1 is equal to 2u by g. What is the u? Say e into v, where v is what? Root 2 gh. You understand this? And in this section, for this is the first rebound, this is the second rebound. So what is the time taken in the second rebound? So t2. What is t2? Say t2 is equal to 2 times, and the velocity is e square v upon g, right? In the same way, that's it. So how to find the total time? The total time taken, capital T, is equal to t. This is the time, plus t1 plus t2 plus t3, t1 plus t2 plus t3. Is it clear or not? This is the total time. I'm doing the second part, right? And the total time is root 2h upon g plus what is t1? T1 is, listen, I'm simplifying here only. The T1 is E into 2 by G into V. What is V? It is root 2 GH, right? It is 2 into E into 2 times root 2H by G. Is it clear or not? It is equal to 2E. So this is the T1. In the same way, what is the T2? T2 is 2E square root 2GH upon G. It is 2E square root 2H upon G. Is it clear or not, you tell? Right. So this is T1 is equal to 2 times of E root 2H upon G, root 2H upon G plus E square time root 2H upon G plus in the next, the T3 2 times E cube root 2H upon G. Is it clear or not? So here what root 2H upon G, you can take common 1 plus 2E plus 2E square plus 2E cube up to infinity. Is it clear or not? So you have to calculate this root 2H upon G, 1 plus, and all these expression you take 2E common. So 1 plus E square up to infinity. So it become what? Infinite GP, right? What is the sum of infinite GP? This is the GP. The first term is 1. The common ratio is E. So the sum of infinite GP is A upon 1 minus R. Do you understand this or not, you tell? And the A is 1 upon 1 minus E. So this is the expression which is equivalent to 1 upon 1 plus E. So I can write this root 2H upon G is equal to 1 plus 2 into E. This is the infinite GP, and the sum is given by this A upon 1 minus R. Right. You may simplify this further, root 2H upon G. Right. This is 1 minus E plus 2E. Right. So it become root 2H upon G and 1 plus E upon 1 minus E. So this is the total time travel you have to remember. Right. How to remember? Although it is a derivation, but you need never to solve this. Just remember, if it is released from rest, what is the time taken? Time taken is root 2H upon G and multiply by 1 plus E and 1 minus E. That's it. So in this way, you can remember the formula total time in rebounds, the total time in rebounds the ball, right? 1 plus E, 1 minus E is multiplied. Copy this. So this is the time period. Sometime they may ask the velocity and the height obtained by the, or the time taken in the after nth collision, in the nth rebounds. So this is the first rebounds, you will remember. This is the second rebound, this is the third rebound, this is the fourth rebounds, right? In the first rebound, this is the speed EV. The second rebounds, the speed is E square V. They, in some questions, they ask the speed after nth rebounds. So after nth rebounds, what will be the speed or the velocity? U square V e ki power n, right? E ki power n into V, and e ki power n root 2 gh the speed is. Do you understand this thing? After nth rebounds, the speed of the ball is. Is it clear or not? Here e raised to the power will n will come, because this is the first, e raised to the power 1. It is the second rebound, e square. This is e cube, like this, right? Now we move to the first part, the total distance covered. So how to find the total distance? You tell. Listen, before this, you can tell me if this is u, right? What is the distance h dash? What is the distance? Final velocity is 0. V square is equal to u square minus 2gh. So final h is equal to what? Say u square upon 2g. Right. This is the h dash plus h dash. This is the maximum height. What is the total distance cover? The total distance cover is nothing but 2 into u square upon 2g. This is u square upon g. Is it clear or not, you tell? Right. So in the first part, for the total distance, this is the h given in the question. So this is the h, right, plus the total distance is, total distance covered is, say h, this is the h. Suppose this is the maximum height h1, this is the maximum height h2, right? So plus 2h1 plus 2h2 plus 2h3 and so on. This is the maximum height h1. And what is the maximum height h1? How to find? The maximum height h1, v square is equal to u square minus 2gh. So the maximum height is what? Say u square upon 2g. Are you getting or not? So the maximum height is h plus 2 into h1. What is h1? U square upon 2g. What is the u over here? Say e square v upon 2g plus 2 times of h2. What is the h2? H2 is the maximum height in the second rebounds. Again, u square upon 2g. In place of u, this is e into v. Wait for 1 minute. This is ev, right? Ev square. What is the speed? This is e square v. Please make it correct. E square v. So here 2 times e square v upon 2g whole square. Any confusion in this expression? Please tell. Yes, copy this first. So now we can put the value. Say h plus 2 into e square v square upon 2g plus 2 into e ki power 4 v square upon 2g and so on. Right. So h upon 2 into e square. What is the value of the v square? The value of the v square is 2gh divided by 2g plus 2 times e ki power 4, then root 2gh upon 2g and so on. So 2gh plus 2 square upon h plus 2 into e ki power 4 upon h and so on. What will be the next term? It will be 2 e ki power 6h. Is it clear or not? Up to infinity. When you will take h common, it will be 2e square plus 2 e ki power 4 plus 2 e ki power 6 up to infinity. I think you are getting this thing. The h1 plus, if you take 2e square common in these all terms, this is 1 as it is, 2 square is common, 1 plus e square plus e ki power 4 up to infinity. Any doubt here? You tell. 2 square e ki power 4 and so on. Again, this is the GP, right? This is GP and this is infinite GP, and this is the A is equal to 1, R is equal to e square, What is the sum of infinite GP? A upon 1 minus R, 1 minus E square. So this is equal to H 1 plus 2 E square, A upon 1 minus R, right? If you simplify this, this is 1 plus 2 E square upon 1 minus E square. Further is simplify, the total distance is H upon 1 plus 1 minus E square plus 2 E square upon 1 minus E square. So the total distance is H 1 plus E square upon 1 minus E square. So this is the total distance. So you may remember in this way. The total distance is what? Say if we consider this is the H, the total height is H, multiply by this is 1 plus E, 1 minus E, 1 plus E square upon 1 minus E square. You have to remember and you can use this direct formula. These are the direct formula, right? Copy this. So this is the thing. This is the ball rebound problem we say. The total time travel and the total distance travel. They may ask anything, right? The speed after nth rebounds, time taken in the second rebounds, like that. So you can do in this way. Okay. Anything else you want to say? You want to ask something? Please tell. Right. Okay. The few more 1-2 questions or few more question we can do on for the inelastic collision. For example, suppose this is the mass m, this is the mass m hanging with the height, right, and this is the another mass, right, and this is the 53 degree, right, and this is the 10 meter, this is also the 10 meter. The mass is it is of 4m, right. When it is at rest and it is released from rest, this is the mass 4m released from rest, so what will happen? It will move and it will collide. So if the coefficient of restitution is 1 by 2, so after collision it will move in this direction, it will raise up to some height. So you have to find the height raised by the B ball, suppose this is the A ball, right? E is equal to 1 by 2 and A is released from rest, right, released from rest. Find the height raised by ball B, right, after collision. If the coefficient of restitution is given in this question is E. This is the question. Copy this. So how to solve this question? There is an inelastic collision. When it will come over here, it will acquire some velocity. First, we have to find the speed, right, acquired by the 4m mass. So can you find this height down by this 4m particle? Yes, we can find. This is 10. This is what? 10 cos 53. What is the value of the 53? 10 into 3 by 5. 5 दूनी 10, 6 meter. So if this is 6 meter, this is 10. So 4 meter is the height round by this. So what is the speed? V is equal to root 2 GH. Can I write it directly? Right. U is equal to 0 and all the potential energy mgh, right, m dash I am assuming mgh is equal to half m dash v square. So m dash will cancel out, so v is equal to root 2 gh, right. The root into 10, the height down by this is what? This is 4 meter, right. So this is 80 root 80 meter per second is the speed. So what is happening now, right? In the solution I am writing, this is the 4m ball, 4m mass ball, whose initial velocity is u. u1 is root 80 meter per second and the another ball mass is at rest. So after collision we have to find the speed of this ball and this is the v2 only, right. After the collision we have to find its speed. So this is the u2 at rest, this is the 4m mass, the velocity is v1, this is the m mass, the velocity is v2. Is it clear? So what is the formula for the v2 if you remember? This is m1 1 plus e upon m1 plus m2 into u1 plus m2 minus em1 upon m1 plus m2 into u2. The m1 is 4m 1 plus e upon 4m plus m, and the u1 is root 80, right, plus what is the u2? It is 0, right? So this is 4 3 by 2 upon 5 into root 80 is equal to what? 6 upon 5 root 80 meter per second. So this is the velocity of v2, right? If you consider this the mass m, after collision this ball will start moving with the speed. So up to what height it will raise, you have to find. This is the height h dash. Again, what will you apply? If this is the reference, all the kinetic energy is converted into mg h dash, right? So mm will cancel out, v2 square upon 2g is equal to h dash. So h dash is v2 square. It means this is 2 into 10, 2 into 10, and v2 square means 6 upon 5 root 80 whole square. You will simplify this, 25 into 20, right? This is 4, and this is 36 into 4 by 25 meter will be the height raised by this ball after collision, right? Copy this. So this is the another question for the inelastic collision. I think the perfectly inelastic collision we have done, right? Well, the perfectly inelastic collision. What is the perfectly inelastic collision? Perfectly inelastic collision. Inelastic collision. What is the perfectly elastic collision when the E is equal to 0? Suppose this the M1 is moving with U1, M2 is moving with U2, and the E is 0. So after collision, they will move with the common velocity V dash, right? So M1 U1 plus M2 U2 is equal to what? M1 plus M2 into V dash. You can apply the conservation of momentum to find the common velocity. Otherwise, yesterday I told you the application of V1 and V2 to find the common velocity. Now, in this case, the loss of kinetic energy is maximum. Loss of kinetic energy. How to find the loss of kinetic energy? Half m1 u1 square plus half m2 u2 square. This is the initial kinetic energy, and the final kinetic energy is half m1 m2 into v dash square. You understand this thing or not? You tell, right? So you can put the value of v dash over here. The half is common, m1 u1 square plus m2 u2 square minus m1 plus m2, and the v dash is m1 u1 plus m2 u2 upon m1 plus m2 whole square, right? So this is equal to half m1 u1 square plus m2 u2 square minus m1 u1 plus m2 u2 whole square upon m1 plus m2. You have to simplify, multiply this and take the LCM. This is m1 plus m2 is the LCM. If you multiply m1 u1 square plus m1 m2 u2 square, m1 m2 u1 square m2 u square minus, right, minus a plus b whole square. This is a square b square plus 2m1 m2 u1 u2. Is it clear or not? So it will cancel out. What will be left? So we will have the loss of kinetic energy we are finding is equal to 1 by 2 in the LCM, in the denominator m1 m2 and m1 m2 u2 square, m1 m2 u1 square. Here m1 m2 is common, and u1 square plus u2 square minus 2 u1 u2, it is equal to half m1 m2 upon m1 plus m2 and u1 minus u2 ka whole square. So the loss of kinetic energy is same, very much similar to the spring problem, right? Maximum compression. This is the relative, this is the reduced mass, and this is the V relative square. This is the loss of kinetic energy, right? Directly you can apply the formula. Otherwise, if you apply the conservation of momentum and then find this way, it will take some time. This is the V relative, right? For example, listen, if this is 2 kg, right, and this is the 4 kg, this is moving with 10 meter per second, this is moving with 5 meter per second. So after collision, they become 6 kg moving some common velocity, and the loss of kinetic energy is equal to what? Say half mu, that is 2 into 4 upon 2 plus 4. And what is the relative velocity? 10 minus 5, because they are moving in the same direction. So 2 upon 3, right, into 5 square in joule is the loss of kinetic energy. For example, if they are moving, this is the 1 kg and this is the 2 kg. They are moving with 20 meter per second and they are moving with 10 meter per second. So what is the maximum loss, right? So the loss of kinetic energy is 1 by 2, 1 into 2 upon 1 plus 2, right? 1 by 2, m1 m2 upon m1 plus m2. And what is the relative velocity? They are moving in the opposite direction. So this is 20 plus 10 whole square. So 1 upon 3 into 30 into 30, right? This is 300 joule is the correct answer. Do you understand this concept? Copy this. So these are the questions, right, related to the inelastic collision, head-on inelastic and head-on elastic collision. Now we will consider now the oblique collision, right? The oblique collision. In the oblique collision, the collision will be of again two types, elastic and inelastic. So first I will discuss the elastic oblique collision. Elastic oblique collision. What is the elastic oblique collision? No loss of kinetic energy, and the line of impact is not the okay, the velocities are not along the line of impact. In the head-on collision, these are the velocities like this. So when they touch each other, they collide. So this is the line of impact or line of common normal, you can say, and the velocities before and after collisions are along this line. But sometime what happen, if this is the u1 velocity, right, it is the u1 velocity, it is moving like this, and the other mass is placed like this. So this is m1, suppose this is the m2. When they hit, suppose it is at rest and the velocity is like this, so the other ball is coming in this way. Are you getting or not? The other ball coming in this way. Is it clear or not? So this is the common normal, or the, you can say, the line of impact. If this angle is theta, suppose, and this ball is coming with the speed u, suppose this is the m1. I am considering the elastic collision, that is the coefficient of restitution is 1 and there is no loss of energy. So if this is u, so this is m1 and this is m2. Suppose it is at rest, this m2 is at rest. Are you getting or not? So what happened? The impulse on the body, in this case the impulse ndt and the impulse ndt acts in this direction, but here the impulse is acting on this body in this direction, and on this body the impulse acted on this direction. Are you getting or not? So what you have to do, you have to consider that the momentum of this body will change along the common normal only. Therefore, the momentum, if this is u sine theta. Are you getting or not? So in this direction, the velocity will not change. In this direction, the velocity will not change. Only you will consider the collision is occurring along this line of impact. This is the line of impact or line of common normal, you can say. Are you getting or not? So after collision, what will happen? So this is the m1 velocity, suppose. This is the m1 mass. So this component will remain same, u sine theta, as it is. It will not change. Only this velocity component is u cos theta. After collision, it become v1. Initially, it was u cos theta. And for this body, this is the mass m2 will start moving with this some speed v2 in this way. Is it clear or not, you tell? Right? And therefore, this is the mass m1, this is the u sine theta component, and this is the v1 after collision. So the resultant velocity will be somewhere like this. So this is the resultant velocity after, I'm writing this is the v dash, suppose. So this is the velocity of the ball 2, so ball 1 after collision, the resultant of u sine theta and v dash, and it will continue to move in this way. It will continue to move in this way. Is it clear or not? In most of the cases, in the oblique collision, one body is at rest and the other body is moving, right, with some other speed at some angle. So these are the cases we are going to discuss. Here the collision is elastic. Along this line of impact, we will apply the same formula. Right, v1 and v2, what we have found, m1 minus m2 upon m1 plus m2 u1 vector 2m2 upon m1 plus m2 into u2 vector, in this way. Right, along the common normal, along the line of impact, we are going to apply this formula. Do you understand or not? Copy this. I will give some illustration, then you can better understand. Whatever you want to copy, you can. So I'm giving an example. For example, if this is the body of the 4 kg, right, it is moving with speed 10 meter per second like this, and here the another body is placed of the mass 2 kg. Right, when it hits, over here, you can assume the radius of this ball is r, and this is the direction of the velocity. This is the 2 kg body. Are you getting or not? This is the 2 kg body, and the radius is again the 2r. This radius is of the r, right? If it is at rest, if e is equal to 0, e is equal to 1, find velocities after collision. Find velocities after collision. Do you understand or not? This is the thing. I will give you 1 minute to think about this. Listen one thing. How to do solution. When they hit, this is the radius r, right? This is the value of the speed u, 10 meter per second, just before the collision. This is the center. If this is r, this is r, this is theta, right? And if this is r, this is r, can you find the angle theta? It is the perpendicular like this. Are you getting or not? The velocity is along this. So what is this angle theta, you tell? What is this angle theta? Or what to do? This is the radius r, right? This is the r, sorry, in this way. Is it clear or not, Varshaz? Yes, sir. So what is the value of sine theta, you tell? Sine theta is the r upon 2r. So this is 1 by 2. So theta is equal to 30 degree from here. You can write in this way. First of all, right, theta is equal to 30 degree. So to find the angle, they may give the r or r root 3 like that. So you have to find the angle, or they may give the angle directly like 30 degree, 50 degree. Here the angle is 30 degree. So what does it mean? So if this is the mass m1, right, this is the a ball, this is the b ball, right, this is the 4 kg, 2 kg, this is the 30 degree. So you will resolve this component. This is the 10 meter per second. This angle is 30 degree, and this component is what? Say 10 sine 30. What is this component? Say 5 meter per second. So the collision will occur along this common normal, and this is the line of impact. After collision, its velocity in this direction does not change. And what is that? Say 5 meter per second. But in this case, what is the velocity with which it will hit? It is hitting 10 cos 30 degree. It is 5 root 3 meter per second. Are you getting or not? So what is happening actually? I'm writing theta is equal to 30 degree over here. In this case, this is the 4 kg body. The 4 kg body is moving in this direction. And what is that velocity? This is the 4 kg body. It is moving with 5 root 3 meter per second, right? And this is at rest, the 2 kg body at rest. Are you getting or not? So in this direction, we have to find the velocity. I can choose this is the m1, I can choose this is the m2. Are you getting this thing or not, you tell? So here u1 I can choose 5 root 3. And what is the value of u2? Can you tell? What is the value of u2? 0. Very good. And after collision, the v1 and v2 you have to find. Are you getting or not? So yes. Okay. Copy this and then I will solve. Because this is the figure, it is a little tough. So we can apply the formula v1 is equal to m1 minus m2 upon m1 plus m2 into u1 plus 2m2 upon m1 plus m2 into u2. What about the u2? It is at rest, so it becomes 0. So m1 is what? Say 4 minus 2 upon 4 plus 2. And with which speed it is coming? It is 5 root 3, right? So it is 2 upon 6, 1 upon 3, 5 root 3. So 5 root 3 upon 3 is the meter per second. This is the speed v1, right? And what about the v2? The v2 is what? It is equal to 2m1 upon m1 plus m2 u1 vector plus m2 minus m1 upon m1 plus m2 into u2 vector, but u2 vector is 0, so 2 into 4 divided by, right, 4 plus 2 into u1 is 5 root 3. So this is 8 upon 6, that is 4 upon 3, 5 root 3, it is 20 root 3 upon 3 meter per second. Are you getting or not? So after collision, this is the 2 kg body. It is moving in this direction, with the speed 20 root 3 upon 3 meter per second. And what about the 4 kg block? Can you tell? In this direction, the component, this is the 5 meter per second, remain as it is. But here it is the v1 component, this is the 5 root 3 upon 3 meter per second. Is it clear, Varshas? So what is the resultant velocity of the 4 kg? The resultant velocity of the 4 kg will be, right, it is 5 square plus 5, this is 5 root 3 upon 3 whole square. And when you will simplify, you will get the correct answer, right? This is 3 and 9, 1 by 3. So this is 4 by 9. This is 5 into 2 by 3. 10 upon 3 meter per second is the speed of the 4 kg block. So it is little tough, but the concept is same. What you have to do, you have to only resolve the component of the velocity along the line of impact and perpendicular to the line of impact. Because impulse is acting in this direction, this component does not change. Are you getting or not? Copy this. Yeah, wait for 1 minute. Wait for. Yes. 5 into this is 1 by 3. This is 4 by 3. Sorry. There is a mistake. Please make it correct. 5 is else common. 3 upon 9. So 1 upon 3. So this is 10 upon root 3. Please check this. So please make it correct. Right. This is the 1 by 9. 1 by 3 multiply 10 by root 3 will be the correct answer. Okay. So now we can do one more question, and very special question. It is asked, right, elastic head-on collision but of masses are same. Have you done this question? The head-on elastic collision, the masses are same. If this is the radius, if this is the mass m, the another body of mass m, it is at rest, right? Head-on elastic collision, oh sorry, oblique collision we are discussing. The mass is same, it is at rest, it is moving with speed u, right? So you tell me what will happen when it reaches to this point. The mass m will be moving just before the collision with the speed u, right? Suppose this is the angle theta. Are you getting or not? The is mass is m. So before the collision it is u, and this angle is theta. So what is component? U sine theta. And what is this component? Say u cos theta. Are you getting or not? So after collision, can you tell me if this is the ball A, this is the ball B? Yes, Varshaz. What will happen then? If this is the u cos theta, this is the u sine theta, and this velocity component is u cos theta. Is it clear? So along the common line, this is the u cos theta, this is u cos theta is colliding with the same mass mm, it is at rest. So along the common normal, the velocities are interchanged. So after collision, what will happen? You tell. After collision, this is the mass m, this is the mass m, will start, its velocity is transferred to this. So what is the velocity of this ball? If this is A, this is B, the B start moving with the speed u cos theta, and in this direction, right, in this direction it is at rest, in this direction, but it has the velocity, the u sine theta it is. Are you getting or not? So this is the ball A, which is start moving in this way. Are you getting? And it is start moving in this way. What is the angle between the velocities? After collision, what is the angle between the two balls? Say 90 degree. What is the angle between the two balls? This is the A, start continue to move in this direction, and this is the ball, it will continue to move in this direction. Are you getting or not? I think there is no need to make this, right? After collision, it hits, it continue to move with the u sine theta in this direction, and this is the ball, the B, it move with the u cos theta. And what is the angle between them? You tell. The angle between them, yes, this is the u sine theta, and I'm making this figure. This is the u sine theta. With the speed u sine theta, they are moving in this direction, right? Suppose this is the velocity v2 and this is the velocity v1. This is the theorem, like this is the like a theorem or result you can think. The v1 speed of the first ball is u sine theta. The v2 speed is u cos theta. So this is the equation number 1 and 2. If you make v1 square plus v2 square, u square cos square theta plus cos square theta, u square. So v1 square plus v2 square is equal to u square, and angle between the ball, angle between balls is 90 degree. Is it clear or not, you tell? This is the solution. Copy this. They will give you the question and directly the condition is that one body is at rest, the masses are same, the collision elastic. For example, suppose this is the 10 meter per second, right? This is the mass m, the coefficient is 1. The head-on elastic, oblique collision occurs right after collision. This is the ball A, this is the ball B, right? The ball A is moving after collision. After collision, ball A is moving with speed, with velocity 5 meter per second, with velocity 5 meter per second. Find the speed of B. Find the speed of B. That's it. So how to solve? Whatever the angle there is given, there is a oblique collision, right? The angle is like the question in the figure, it is given there. So what will you do? After collision, the ball A is moving somewhere like this, and definitely the ball B will be moving perpendicularly. So its velocity will be 5 meter per second as told by the question, right? And what is the V2? We can find this is the V1, this is the V2. V1 square plus V2 square is equal to what? Say U square. So this is 5 square plus V2 square is equal to 10 square. It is 100 minus 25 is equal to V2 square is equal to root 75, 5 root 3 meter per second. That's it. If you don't know this thing, you cannot solve this. Do you understand or not? Also the angle, they ask the angle between the two masses, the 90 degree, and the velocity relation is this. Copy this file. Okay. So this is the elastic oblique collision. Now we will consider the inelastic oblique collision, right? Inelastic collision. If you understand this elastic collision, oblique elastic collision, you can understand. Suppose I'm taking an illustration directly, right? Suppose this is the 10 kg block, right? And there is another ball. This is the 4 kg, suppose. Are you getting or not? So this is the speed 28 meter per second, right? When it hits this 4 kg block, the angle is given. Suppose this is the angle, right? This angle of the initial velocity is 28 meter per second. This given is the 37 degree, suppose. Are you getting or not? If E is equal to what? Say 1 by 2. Find velocities after collision. Velocities after collision. Do you understand the question or not, you tell? Right? Yes. Copy this. This is the oblique inelastic collision. Copy this. So in the same way, we have to solve this question. Suppose this is the 28 meter per second. We will resolve the component. This is the 37. This is the 28 cos 37. This is 28 sin 37. What is the value of sin 37? It is 3 by 5. Wait for 1 minute. Yes, this is 28, 3 by 5, suppose. This is the 28, right, cos 37, 4 by 5 it is. Are you getting or not? So this is the velocity. Okay, whatever the velocity it is, this is the, now the collision is occurring. This is the u1 velocity. The u1 velocity is 28 into 4, 8 चौक 4 अट्ठे 32, 4 दूनी 8 और 3 11 बटे 5, 112/5 meter per second, and it is at rest. Generally the second body is at rest, but it is not necessary. So this is the 10 kg block. It hits with this. Are you getting or not? This is the u2 is 0. So after collision, this velocity is the 28 sine 37. It remains as it is, right? This is the 4 kg block. So if you consider this the 10 kg ball, so this is the v1 velocity, suppose, and after hitting, this is the v2 velocity of the 4 kg block. In this direction, the velocity component remain, right? 28 3 अट्ठे 24 3 दूनी 6 और 2 8 84 upon 5 meter per second, right? 84 upon 5 meter per second. Is it clear or not? So how to find the v1 and v2? Listen one thing. We have the formula. The v1 is m1 minus em2 upon m1 plus m2 into u1 plus 0. Why it is 0? Because u2 is 0. So the m1 is what? 10 minus 1 by 2 into 4 upon 10 plus 4 into u1, 112 upon 5 plus 0. Find the v1 and then v2. You tell me, Varshaz, you are getting the concept or not? You tell. Yes, copy this. So this is 8 upon 8 upon 14 into 5. तो 7 दूनी 14, 7 एकम 7, 7 छिंग 42, 2 अट्ठे 16, 7 एकम 7, 7 छिंग 42 और 7 दूनी 14, 2 अट्ठे 16, 64 upon 5 meter per second. So this is the 68, 64.64 by 5 meter per second. And what about the velocity v2? The v2 formula is it is m1 1 plus c upon m1 plus m2 into u1 plus 0. Why? Because the u2 is 0. So m1 is 14, 1 plus 1 by 2 upon 14 plus 4 into u1. This is the u1, 112 upon 5. So this is 7 into 3 upon 20 upon 10 plus 4, it is 14 into 112 upon 5, right? 14 अट्ठे 14 अट्ठे 112. This is 8. 14 8 ja 112, right? And this is 7 या 21 into 8 upon 5. 8 एकम 8, 8 दूनी 16 बटे 5. So its speed is 168 upon 5 meter per second. Listen one more thing. These are the components after collision. So this component only change. If you consider the ball A will move at some angle, not at 90 degree always, right? It is moving in this way and it is moving in this way. So the angle between the ball A and ball B will not be 90 degree this time. The angle will be some else, right? Like this. So we are not finding the angle, rather the resultant velocity is a root over this component square plus 84 upon 5 component, right? When you will simplify, you will get the answer. You are getting the concept of inelastic collision, Varshad, right? So these are the balls when they are colliding, right? In the next lecture, we will start with the wedge and the ball problem, right? They hit at some angle, and I will finish in the next lecture, right? Copy this.